today's video is on the relationship again between pressure and volume. Now, if you are doing combined science, you do not need to know this, okay? Whilst you're very welcome to watch this video and you might find it useful, you do not need to know this. If you're doing triple science, so you're doing physics as a separate GCSE, then listen up, you need to know this, okay? Now, if you want more content like this or more information on this topic, check out my resources on the My Edspace website, or you could have a look at joining my live lessons using the link in the description for this video. Let's get started, shall we? So, we're going to do a very quick recap. So, the relationship between gas pressure and volume is inversely proportional. As one thing gets bigger, the other thing gets smaller. So here, we've got these particles rebounding from the container wall, okay? That is causing gas pressure. Now, if I reduce the volume, so I squash the same number of particles but into a smaller volume, I'm squashing those particles closer together. So I reduce the volume, so the particles are closer together and have less space between them. Because they've got less space between them, we're going to get more frequent collisions with the container wall, and more frequent collisions with the container wall means that we're going to get an increase in gas pressure. Now, if we don't change the temperature or the number of particles in our container when we compress it, the pressure multiplied by the volume will always equal the same number. We found this out experimentally over hundreds and thousands of experiments, okay? And there's more information on that experiment on my resources on the My Edspace website. But what you need to know is that we came up with this equation here. The pressure times the volume equals a constant. Now, the constant will change for each setup that you're given because it depends on the temperature and the number of particles. But as long as those two things don't change, so for example in my example here, I've still got the same number of particles, temperature's the same, so the pressure multiplied by the volume for each of these would be the same. So P in this equation stands for the pressure, which we measure in pascals. Occasionally you'll see that in kilopascals. And V stands for volume, which we'll measure in meters cubed. Now, one of the great joys of using this equation is we can be a little bit lazy with our units if we need to be, okay? If you put the pressure in pascals, the pressure will come out in pascals. If you put the pressure in kilopascals, the pressure will come out in kilopascals. Same thing for volume, is that if you put the volume in meters cubed, the volume will come out in meters cubed. If you put the volume in centimetres cubed, the volume will come out in centimetres cubed. So it's really nice to be able to use it like that. Let's do a quick example because it sounds quite confusing until you see it in action. So I've got a flask here that I've stoppered that's got a volume of 40 centimetres cubed under a pressure of 150,000 pascals. I compress the volume so that I've now got the same number of particles at the same temperature, but in 15 centimetres cubed of volume this time, and I want to find the new pressure. So the first thing I'm going to work out is I'm going to work out what this constant is in the first one up here. So I'm going to do 40 multiplied by 1,500, which gives me an answer of 6 million. Don't worry about the unit, it's just a constant. Now, I know that because I've got the same number of particles and they're at the same temperature, that my new volume multiplied by my new pressure is also going to equal 6 million. So the pressure, which I don't know, multiplied by the volume, 15, is equal to 6 million. I'm going to do a very quick rearrangement. I'm going to divide both sides by 15 get the pressure on its own, which gives me an answer of 400,000 pascals. So this is how we can use this equation to help us solve problems just like this. For more examples and more worked solutions, check out my resources on the My Edspace website. You can have a look in the description of this video to have a look at joining my live lessons. And whilst you're there, hit subscribe for me as well. Thank you very much. I hope you enjoyed this video and I'll see you in the next one. Bye for now.